Hi everyone. Today we are going through the process of constraining a buckling factor for MSC Nastran Optimization. My name is Christian. If you want more advanced training, if you want to work with me on a project of your own, feel free to reach out to me and I'd be more than glad to have a discussion with you. I'm going to go through a brief discussion of the model. I'm going to go over what our optimization problem statement is, what exactly are we optimizing, and then I'll go through the process of applying a constraint on a buckling factor. Here is to give you an idea, we are dealing with a member that's fixed on one end and applied with the compressive load at the top. This rod, if you will, is 12 inches in length. It has a cross section with the radius of 0.25 inches. And right now, the buckling load is 520 pounds. But this structure is being applied a load of 100 pounds. So you can see we're still within the buckling failure load. What we're going to do, we're going to minimize the weight of this structure. We're going to let the radius of the cross section vary. What we're going to say is the buckling factor should always be greater than 1. So in a way, we're saying that the buckling factor should have a lower bound of 1. And so right now, let me go ahead and go through that process and construct this for MSC Nastran. So if you start with the web app, this web app is available in the more advanced training I provide. If you click on constraints, you can change the analysis type to buckling. And if you go, you have an option of selecting buckling factor. Click on that one time to create your buckling constraint. This is where we are going to say the buckling factor should always be greater than 1.0. And this is going to be for the first buckling mode, so buckling mode 1. If we look in Patran, our current buckling factor is 5.25, and that is with the compressive load of 100 pounds. A buckling factor greater than 1 means that we're still far from exceeding the buckling load of the structure. By saying impose a buckling factor constraint that should be greater than 1, that will allow the radius to either decrease or increase ultimately until it faces that constraint. So now let's go ahead and copy these statements from our web app and paste those into our design model of this model. This design model already has the objective and the design variables filled in. I just filled in the design constraint statements. Let's go ahead and now perform the optimization. And let me actually close some of these applications just so it doesn't slow down my machine. The reason I'm doing this, I'm running a virtual machine that's already starved of memory, so I want to make sure I have enough memory for the optimization. And here, let me rerun that. And we will go ahead and inspect the F06 file just to make sure the analysis completed successfully. And at the very bottom, we find run terminated due to hard convergence. Now, before we inspect any further, let's actually view the structural results. During the optimization process, a new result file was created. This contains my original buckling results and my new buckling results. So I'll attach that to this database. And I'm going to view what my original buckling factor was. So let me go here and plot this. So this was our original buckling shape. And this was, or rather it really isn't a buckling shape since our buckling factor was 5.25. If you note here at D5, which is the last design cycle, the buckling factor is now 1. So now we are at a point where the radius is new And at this new radius, we achieve a buckling factor of 1 for the given load of 100 pounds. The question now is, what is the new cross-section radius? And here I have this summarized at my slide. I find that the radius before was 0.25, and for the given loading gave a buckling factor of 5.25. Now for a radius of 0.17, this produces a buckling factor of 1. This is where, in this structural configuration with this dimension, this is where you experience buckling. This 0.17 can be derived from the F06 file, where in initial design, this is the original radius of 0.25. Here at the very final design cycle is where we have our radius of 0.165, which is 0.175. So that's how you impose a buckling constraint. Again, if you have any questions, comments, if you want more training, if you want me to work with you on an optimization problem of your own, if you want access to this web app that lets you create your optimization models, feel free to reach out to me at this email address, and I'd be more than glad to work with you. Thank you for watching.